Hello, guys. This is chapter 26. Um, and it's basically asking us to find the EMF of battery X and determine its polarity. To find the currents through this 200 volt battery. So find X, find the find the currents on the 200 volt battery, and then find the value of R. So to find I, to find X, so the voltage, and then to find the resistor value. Okay, perfect. So we're just gonna focus on A right now. So as for A, to find the EMF of battery and determine its polarity. So to find the EMF of battery X, first let's read our knowns. We have so we have I is equal to 5 amps. So this is the currents flowing through the 20 volt battery. And then we have a junction right over here, and we can actually just draw that junction real quick. So we're going to label this I2. This is going to be I1, and then we have I3. And we know that I1 is equal to 5 amps. And then from here, we can say that I3 is equal to I1 minus I2. And then we can actually solve for I2 here, because the current that flows through this middle part right here is actually just 1. So we're given the voltage across the 8 ohm resistor is 16 volts. So we can just solve for the currents flowing on this 18 volts right here. I mean, flowing on this 8 ohm resistor. So we can use Ohm's law. V is equal to IR. So I is equal to V over R. So I is just equal to 16 volts over 8 ohms. So we can just say that I2 is equal to 2 amps. So since we have I2 is equal to 2 amps, this gives us an I3 of 5 amps minus 2 amps is equal to 3 amps. And this actually answers our number 2 question, because the current flowing through here are all the same. So the current flowing through the 200 volts battery is just 3 amps. Cool. So going back to question A, find the EMF of battery X and determine its polarity. Cool. So now that we have all the currents in our circuit, we can go ahead and just solve for the resistor equivalence for these extra notch extra circuit right over here on top. So we can just find the R equivalence for this one, and then this one I'm going to do on blue. So for this part, it's going to be R equivalence. So we can say that the blue R equivalence, or the left hand R equivalence, is equal to 1 over 20 plus 1 over 30 to the negative 1. And then we plug this into the calculator, we will end up with, I believe, let me see. $12 ohms. And then I'm going to do the other one in a different color. This would be REQ on the right hand side. We can do the same thing. 1 over R plus 1 over R, since they are in a parallel. And then the inverse is just R over 2 ohms. We don't have to write that because we don't have an actual value for R. So now that we have this, we can actually just redraw this circuit. Okay, and we can go ahead and just do that real quick. So we're gonna redraw the circuits, but instead of having these extra resistors at the top, we're just gonna draw them as one resistor in a series. So we have sorry. Cool. Okay. So we have our X right here. And then we have our 8 ohm resistor right over here. And then we have R over 2. And then we have a 12 ohm. And then we have an 18 ohm. And then we have a 20 volt battery. We have a current flowing this way. And then we have our 200 volts. We're going to go ahead and just rewrite our I's real quick. So our I1 is equal to 5 amps. I2 is equal to 2 amps. And then I3 is equal to 3 amps. Cool. So we have two unknowns. We have R and X. So this means that we need 3 equations. So for this circuit, we're following the motion of the electrons. So since it's flowing from the 20 volt battery, electrons are flowing from here going to this side. So we can just say that this would be negative and this would be positive. And since this is positive, this resistor would have a negative right there and a positive right there, and then it just alternates. And this is actually how we are going to find the the EMF value for X. So we can just look at this single loop to find the value for X, since it's our only unknown. And then we could also end up looking at, so we could just look at the second one later. So this also flows this way because the current is flowing this way, but this side is against the, since the currents for this side is going this way and the loop is going this way, this is going to be a little bit weird since it's two unknowns if we do the right side. So we're just going to stick with the left-hand side. So when writing down the left-hand side, so we're just going to use Kirchhoff's loop rule. So Kirchhoff's loop rule says that the voltage across each resistance and the voltage across this voltage source and this X is all equal to 0. So we can go ahead and just start from our 20 volt battery here. So since we are looking at the movement of electrons, this would be written as a negative 20 volts minus, or sorry, this would be a plus. And then since this is going from negative to a positive, this will be a plus X. And since this is going from a negative to a positive, this would be minus 8 I2. And then again, negative to a positive, this would be a minus 12 I1, since everything on this left hand side would be I1. And then we have minus 18 I1 equals 0. And then we can go ahead and just rearrange this in terms of x. So x would just be equal to 20 volts plus, this would be 8 times 2, 16 volts plus 12. This would be 12 times 5 is 60 volts plus 18 times 5 is 90 volts. So quickly, we can say that x is equal to 186 volts. And the direction is from positive, so the direction is from positive to negative, going this way. So we can say that x is equal to 186 volts with the orientation to the direction flowing that way. We can just honestly say that this is negative 186 volts since it's going down, but we'll just leave it as that. So perfect. So after we solve this, now we can solve for the third, for C. Find the value of R. So find the value of the resistor. To find the value of the resistor, we need to write the the right side now. So the right side in terms of Kirchhoff's loop rule. Cool. So we're going to go ahead and just erase this. And then we're just going to erase this side, so we don't need it. Actually, maybe we need it. You know what? I'll leave it here, but mainly we're just focusing on this side. I'm going to go ahead and just redraw it real quick. So we have our 8 ohm resistor, and then it's flowing this way. So it's going this way. Cool. So we have our R over 2. We have our 8 ohm. We have our 186 volts. And then we have to make sure that we write the orientation, so plus to minus. And then we have our I3. We have I2. Okay, cool. So since this is what we're looking at, we can go ahead and just solve for this using the Kirchhoff's loop rule. We have 200 volts. So since, again, we're looking at the flow of electrons, so we're just going to go ahead and just follow the electrons. So if electrons are coming out this way, eventually they'll pile up here, go for positive, minus, plus, and at this 8 ohm resistor, we actually already have the orientation for the voltage. We already have the flow. So we're just going to leave that as is. We're going to go plus, minus, and then plus, minus. Cool. So let's go ahead and do this loop following the movement of the electrons. So again, we're moving this way. Okay, cool. So we're going to start with this 186 volts battery here. So since we're moving with the flow of electrons, we're going to go minus 186 volts. We follow the currents. It's going to be plus 200 volts. And then it's going to be minus to a plus. So it's minus. This would be I3. I3 R over 2. And then this plus to a minus would be plus 8 I2 equals 0. So we can go ahead and just solve this real quick. This would be 14 volts minus I3 is 3 amps. That is given. So 3 over 2R plus 8 times 5 is 90. So we can go ahead and just isolate for R here. R is equal to 104 volts. Sorry, I meant 16 for this. I thought it was 18. Thought it was 18 volts. This should be 8 times 2 is just 16. I'm so sorry about that. 14 plus 16 is just 30. So then this would eventually give us R is equal to 30 times 2 is 60 divided by 3 is 20 ohms. So then to find the value of R is just equals 20 ohms.